Numerical 5.1. Find the gravitational force of attraction between the two spheres, each of mass 1000 kg. The distance between the centers of the sphere is 0.5 meter. We have the two masses M1 and M2, and the mass of M1 and M2 is 1000 kg, and the distance between these two spheres is 0.5 meter. We have to find the gravitational force between the two spheres. So first of all, we will write here the value of given data. Mass M1 is equals to 1000 kg. Mass M2 is also equal to 1000 kg. And the distance between the sphere is 0.5 meter. 0.5 meter. We have the two spheres. This is M1, this is M2. M1 mass 1000 kg, M2 mass is also 1000 kg, and the distance between these two spheres is 0.5 meter. We have to find here the gravitational force between the two spheres. Gravitational force F we have to find. To find the gravitational force between two spheres, we'll use the formula F is equals to capital G M1 M2 over D square. Now we will put the values and start the solution. F is equals to capital G, the value of capital G 6.673 multiplied 10 raised to power minus 11. M1 and M2 1000 kg, and the value of D distance is 0.5 meter. Now we will find the answer of this. So its answer is 2.67 multiplied 10 raised to power minus 4 Newton. (5.2) Numerical. The gravitational force between the two identical lead spheres which are kept at 1 meter apart is 0.00673 Newton. Find their masses. Now we have the two masses M1 and M2, and we don't know their masses, but the gravitational force between these two masses is 0.006673, and the distance between these two spheres is equals to 1 meter. Here we have to find out the value of masses M1 and M2. So first of all, we will write here the value of given data. Gravitational force F is equals to 0.00673 Newton, and the distance between the sphere is 1 meter. Distance is equals to 1 meter. We have to find the value of masses. Mass M1 and mass M2. For this, we will use the same formula of previous numerical. F is equals to capital G M1 M2 over D squared. Now we will rearrange the formula because here we have to find out the value of mass. We will multiply F with the D and divide with the capital G. So here we will rearrange the formula F D squared over capital G. It is equals to M1 M2. m1 is equals to m2 and m2, both m1 and m2 are equals to m. So we will write here FD square over capital G. M1 is also equals to m, m2 is also equals to m. So we will write here FD square over capital G is equals to m square. So now we will put the values inside the formula. The value of f is 0.006673. The value of distance is 1 square and the value of g is 6.673 multiplied 10 raised to power minus 11. M square is 0.673 multiplied 10 raised to power minus 3. 6.673 multiplied 10 raised to power minus 3 because we have moved the decimal till 0.6. 1 square, 1 is also equals to 1 and this value will be same, 6.673 multiplied 10 raised to power minus 11. These two values are same, so they will cancel with each other. M square is equals to 1 multiply with the 10 raised to power minus 3 and this minus value will be changed into the plus value. M square is equals to plus minus minus 10 raised to power 8. So M square is equals to 1, 2, 3, 4, 5, 6, 7, 8. We will take the square root both sides of the equation and it will becomes equals to 10,000 kg. So the mass of each sphere in this case is 10,000 kg. Numerical 5.3. Find the acceleration due to gravity on the surface of Mars. The mass of Mars is 6.42 multiplied 10 raised to power 23 kg and its radius is 3370 kilometer. So in this value, in the given data, we have the value of mass of the Mars, radius of the Mars, and we have to find out the value of acceleration due to gravity, gravitational acceleration value on the surface of Mars. So first of all, we will write the value of given data. Mass of Mars, mass of Mars m is equals to 6.42 multiplied 10 raised to power 23 kg. Radius of Mars, capital R, is equals to 3370 multiplied 10 raised to power 3 meter. We have to find here the value of gravitational acceleration. Gravitational acceleration on the surface of Mars. For this, we will use the formula G is equals to capital G m over r square. After that, we will start the solution by putting the values inside the formula. The value of gravitational acceleration on the surface of Mars, the value of capital G 6.673 multiplied 10 raised to power minus 11. The value of Mars, mass of the Mars 6.42 multiplied 10 raised to power 23, and the value of radius is 3370 multiplied 10 raised to power 3 square. Now we will find its answer. Answer is 3.77 ms minus 2. Numerical 5.4. The acceleration due to gravity on the surface of moon is 1.62 ms minus 2. The value of g is given in the statement. The radius of moon is 1740 kilometer. The radius of moon is also given. We have to find here the mass of moon. So first of all, we write here the value of given data. The value of g, gravitational acceleration, is equals to 1.62 ms minus 2. Radius of moon r is equals to 1740 multiplied 10 raised to power 3 meter. We have to find here mass of moon. To find mass of moon, this we have to find, and we will use the formula G is equals to capital G m over r square. After that, we will rearrange the formula. We will multiply g with the r square and divide with the capital G, because we have to find out here the value of mass. So g r square over capital G is equals to m. Now we will put the values inside the formula. The value of g is 1.62. The value of r 1740 multiplied 10 raised to power 3 square, and the value of g 6.673 multiplied 10 raised to power minus 11. The answer is 7.35 multiplied 10 raised to power 22 kg.